My name is Ruud Henkes. I'm 1 day a week professor here at Delft University, working on multi-phase flow in pipeline systems. So it's clear that pipelines play an important role in all type of industrial applications. If you go to chemical plants, in order to get the connection between various reactors, you need pieces of pipe. So it's very important to know how pipeline systems work. But fluid flow behavior itself can be complex, as you probably already know. Depending on the fluid flow velocity, the fluids can behave as a laminar flow, but it can also, at higher flow rates, undergo a transition to turbulent flow. That depends indeed on the flow velocity, but you can also scale that and look at a single dimensionless number. And the most famous dimensionless number in fluid flow is the Reynolds number. It's important to know what the Reynolds number is and what the state of the flow is, because that is linked to how much pressure drop you have in your pipeline. And that, of course, is a measure on how much energy is required to transport fluids, gas or liquid through a pipeline system. We are here in the laboratory of process and energy, and we do research with the help of bachelor students, master students and PhD students. And some of them do experiments with pipe flow. And there is now a master student, and he's going to show you a bit on what he is doing.
My name is Harm. I'm one of the master students here, and I'm currently working on my master thesis, where I'm looking at small devices moving through pipelines to clean the pipe internally, and my measurements are focused on the behavior of these devices. There are several pressure probes where I can measure the pressure and thereby say something about the behavior of these devices, and say something about the behavior of these devices, but then on an industrial scale.